How's it going, everyone? Julier Gonzalez again. But in today's video, we're gonna take a look now at the NeetCode, this series of or this roadmap as a way to see how all of this, particularly data structure and algorithm, works by discovering is the patterns to solve real life problems. So by using is now data structure like array, hash, linked list, double linked list, stack, queues, graph, and trees, and algorithms like binary search or search and sorting, right? We're going to develop this sense when it comes to look at the particular patterns that happens in real life problems, and then we can come up with some solution to that. So this particular roadmap was created by Nadeep Singh, which he previously worked at Capital One and then as Google intern. And well, he launched actually this uh, academy, sort of speaking, as a way to know is the way of how he actually solved each one of these problems. That is not only to crack the coding interview, but also is to understand how each one of those particularly data structure and algorithm are helpful when it comes to solve real life problems for this pattern recognition that you're going to develop as a way to solve real life problems with these particular tools. And you can boil down a lot of the time to geometry and arithmetic. Geometry, arithmetic, and algebra. I will argue that that all is the basis. Uh, so in today's video, the methodology here is that we're gonna take is the first 10 minutes to describe what we went through, what is the value proposition of each one of those problems that we have solved. 20 minutes to actually learn and read and understand the particular problem of today's video, and if we can, then jump straight forward to the solution. So because so far we started with the array and hashing, okay, as a way to see how you can work with this particular data structure to solve common problems like contains duplicates or valid anagram, as a way to see how you can work now with one data structure to another with strings and hash and collections of arrays or an array. Uh, Also the two sum, which was very interesting problem completely. As a way to find out what is the two index here. What is the index, or what is the two number index that in a collections when you add them it match to a target. So this is as a way to see what are the combinatory things and see how you can actually come up with a particular solution, which in this case is by iterating through all of these elements, and they guarantee that there's a unique solution. Okay, you can count each one of those elements, and the idea here is to develop an algorithm that do that. And as we iterate through that, we're gonna check that or hash in memory. Similar to the group anagrams, where the idea here is that how you can actually use is now arrays and a hash as a way to now store all of these elements per se. This three exercise to me was one of the most mind-bending and quite frankly interesting, because this is something that you can solve in real life. So as a way to say what is the most n or k frequent elements, giving a collection of values. So here we use is now the arrays and a hash as a way to count the number of occurrences that elements happen in a collection. Once you get that information, we're gonna use this an array as to represent now in each one of those index the number of occurrences that they can happen. So you can see you're starting to develop this particular notion that is the representation And how representation in software engineering is something that we are always doing. So we want to abstract or represent something for that. So after we identify that in our array, we're going to now look at each one of those elements, or we're gonna, in this array, where each one of those index represents is the number of occurrence of those elements, then once you have that array, you want to reverse that and get the most frequent elements out of that. So this is something very interesting because here, as you can imagine, or as you can think, you started to use geometry here first as a way to identify all of these elements, okay? And what you need to do with all of these elements, we can represent those elements with a square box, okay? And then actually think about how you can now work with that problem as it is. And of course, by applying some arithmetics, which is the how you count number here, the art of counting, as well as some generalizations that you can do for this, which is the algebra. And the other is the decode and encode, as a way to say how you can now is by encoding and a collections of elements that you receive as a string, which is adding some information that we're going to represent is some information that we're going to use later on to decode that data. And here we started to see how we can now start to work with something called like pointers as a way to extract that data as we need it. And I think that's quite interesting. Similar to the product array of Excel, except Excel as a way to now calculate is a prefix and then the postfix and merge that. Or in other words, by calculating is a prefix and then add the value as you calculate is a postfix to each one of those collections, you can get is the product of all the values as array except self. Similar to the Sudoku, but in this case it was more like using the representation. First, following is the particular rule that the Sudoku has, which only on the row on a row must not contain duplicate. The same for the column, and for each one of those square. Now, how you going to represent each one of them as a matrix as well, with the length of 2 by 2 or 3 by 3. But because we're counting with index, it is 2 by 2. But this is the way of how you can now represent elements in there in your set. So this to me is quite interesting. Totally. Because now you develop this particular sense and when it comes to look at now how you can solve, for example, problems like this, like valid palindrome, which is now part of the 2 pointers. It was quite straightforward here. I didn't even look at the solution for that at the palindrome because the idea here is a palindrome is a word where it's a phrase where now all of so when you take that words and reverse that it contains they are equal, okay, unlike anagrams, which is per words. Palindromes are for phrase or for sentence. So it was actually quite interesting because here we look at, for example, now how we can work with the match function that JavaScript provide for us as a way to identify each one of those elements in there. And therefore, we're going to now construct our own string as it is. And then once we reverse, we need to check if that actually is the same. With the palindrome that we create from that string that we receive, and when we reverse that, if that actually has, is that the same. So that was quite interesting, most likely to see how can we work with regular expression, regex. And in today's video, we're going to take a look now at the valid parenthesis. This particular exercise, like so, valid parenthesis. And let's get to it. Let's get into this. So giving a string s containing just the character, okay. Giving a string s that contain only this character, this one, and 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 this one. So curly braces, and a parenthesis, curly braces, and square, okay. Determine if the input string is valid. An input string is valid if open bracket must be closed by the same type of bracket, like this. And they even use now use a stack of character. They actually giving you a hint for that. I don't know where this hint comes from, but that's fine. Open bracket must be closed by the same type of brackets, okay. Open bracket must be closed in a correct order, and every closed bracket has the corresponding open bracket of the same type. So what it means is that we are giving that particular input here, determining if the input string is valid. As an input string is valid is that open bracket must be closed by the same type of bracket, and open bracket must be closed in the correct order. It must be closed in the correct order. So the order here matters, okay. And okay. So open bracket must be closed by the same type of bracket. Open bracket must be closed by the correct order, and every closed bracket has a corresponding open bracket of the same type. So because here order matters, and we know that a call stack is a way of giving our experience, right? And we will know that the call stack is how we can keep track, or call stacks are how a computer keep track the execution of a program, okay. Here we can use now a stack as a way to see if we got that. As a way to see if we got that, right? As a way to see if we got that. The question here will be is like, this is when the geometry in draw.io kicks into place, right? I don't want to actually, open or create a new diagram, like so. All right. So here's what we're gonna do is this. So because each one of those tokens here, we actually use this a text here. There's a text. Yeah. So each one of these characters. So for example, if we evaluate each one of them, and then you close this, and then you have this, and then you have another character here. What in the F? There you got it. And then you got is this one. Okay. So here, because now this is our string or collections of elements. Actually, let make this way bigger here. That's right. So the idea here is that by having this, okay, and we're gonna do is this. We're gonna represent each one of them as a collection here, okay, which means that this is a particular box, Okay, I would like you to draw something here. Isn't fill line, that's right, exactly. So this is our first token, right? So this is our first token. Then we got a second token, which is now this. All right, I don't know why you put that so low. You should have this as 36. Oh, you think you're funny. Okay. Followed by the next element, which is this one. I don't know why you do that. Is there any particular reason? Okay, anyway. The next element here is this. No. Oh my god, what the hell? Okay. The next element is this. The other element is this. Like so. Oh. Okay. Like. Oh, for real? Like this. And last but not least is this element. As you can see, this is not a valid one. Okay? Because following by this, open bracket must be closed by the same type of brackets. So we need to find a way to keep track of that. Open bracket must be closed in the correct order. Okay? So open bracket must be closed in the correct order. So order here matters. And every closed bracket has a corresponding open bracket of the same type. So because of this condition, if we go through this and say, hey, how can we actually know that this collection has the proper order here? Well, we can use perhaps is now a stack. Okay, where we can say, hey, let's go to now find this first element here in our stack. Put this here. This will be our stack. Okay, what? No. Text. This will be our stack. Okay. This particular data structure where we're gonna put. Okay, actually, put this right below here. Okay. Where with the stack we will now know is the order in which we are actually adding all of these elements. So what we can do is to have now a stack for curly braces, and a stack for parentheses, and then a stack for yeah. So and then a stack for parentheses. Okay. So one way we can do that is by having it in this order, right? So a stack of parentheses. Okay. So a stack of parentheses, and a stack of and a stack of curly braces, and a stack of parentheses, and a stack of and a stack of square brackets. Yeah, because this is one of them, right? Here's this one. So with this, okay, because the first iteration, we're gonna add that to our stack here, to the parenthesis stack. The second time, okay, the second time, yeah, because the first time you're gonna add this stack here, you're gonna have the stack of parentheses. Then you're gonna identify this symbol, and then you're gonna say, hey, if this is actually a parenthesis, I'm gonna add to this particular stack. Okay. The next element is now this, so you can now add it to the particular stack. Okay. Like so. So we add it to that particular stack. Let me actually. Okay. Yeah, it'll be much better like this. Similar to this. This is our another stack here, which is this, and this is our another stack here, which is here. Got it. Okay. Cool. The point that I want to make here, okay. Well, okay. And the same here, like this. All right. Okay. So the point of doing this is as a way to know how you can solve this particular problem. So a stack is something that you add at the top, okay? Vertical container. Maybe actually use some of this line, okay? Like that. No. Here, okay, similar to this, we're gonna copy this like so, and then I would like to add now this stack right now, like so. All right, and then join them with this. Join them with this particular line like this. No, and the other will be is here. All right. So this is our stack, right? Yay, our stack. Let me actually do this. We copy, we paste here. Oh my God. Oh, I need to group that. That'll be great. I'm actually I should use this Figma, but in any case, that was the first thing that came up with my mind. Group them. You paste that for a duplicate. That's right. You got it. And the other one is here. And there you got it. All right. Good. Good. So the next time. So we don't have anything right now. So this is great because now we can is the order in which we are adding all of these elements, right? So as we iterate to the first, in fact, let me actually quit this, right? So as we iterate the first element, we're gonna check if that actually is a parenthesis. If it is, we're gonna add that to the stack, okay? Then the next element is a parenthesis, a curly braces, and the previous one, and now the parenthesis where this is something that we're going to add to our stack. All right, the next element is now a parenthesis, a curly braces. What happened here is that this is an open curly braces, so it needs to have a matching closing argument, right? So if we go to the next one, which in this case is this element, we're gonna add to our stack here, okay? We're gonna add our stack, and here we got is now 3 elements, okay? So we have is the order in which we have inserting elements here, and we have now is the number of them as well. The next one is a closing one, which so far so good. It is great because so far it's actually matching is our valid one, not that old, by the way. Uh, and the next element here is now a square brackets, which is something that we add to this element here. And last but not least, we add this last new elements here to this. The thing here is this: we need to reach to the end of the elements because we need to check if this actually has a or follow these conditions. So an open bracket must be closed by the same type of brackets. Open bracket must be closed in the correct order. Okay. Open bracket an open bracket must be closed in the correct order, and every closed bracket has a corresponding open brackets of the same type, right? So because with our first stack, where we have now 5 elements here, okay, as you can see here, even though that we have this 5 elements here, so impair names, impairs name in our stack means that this is not a valid, so we can check that. Okay, so if we have impair values, if we have impair or we have an odd, no, if we have an odd in number, okay, if we have an odd number of elements here, okay, it means that that is not a valid. In each one of our stack, if we have an odd number, it means that it's not valid. However, because the order here matters, okay, you say open bracket must be closed in the same types. Open brackets must be closed in the correct order, which means that we will need to check if that if you have now an opening and a closing tag, all right. Which means that we will need to have is that okay, we will need to check if in that stack, okay, we will need to check if in that stack okay, we will need to check in that stack if these elements that we're adding or that we're gonna push to that is something that actually match the order, because the order here matters. Okay, one way to do this is by doing something like this. Okay, so once we have our particular stack with this, as we pop up elements from here and where the order matters, okay, in which the order matters, Hey, but where we got some? There's missing one. There is a missing one. There is a missing one. Okay, there is a missing one. Hmm. Okay. There is a missing one. Because this stack guarantee is the order. Okay? So, because this stack guarantee of the order, and if we for some reason we have something like this, we remove the element there, and then we say something like this, all right? So even though this is not a valid one, all right, because the other characters are now closing, are now opening and closing that, all right. So one way we can do this is by now using an stack, okay, and check for each one of those stack if we have an odd pair of element. If we have them, it means that that is not a valid. Yeah, if we have them, it means that that is not a valid a string or not a valid parenthesis, right? Because, for example, if we now remove this element here and we add now another element here at this, right? And we say, hey, now this will be is this one. Enough. I think you're funny. Okay. Which is now adding instead of having this element here. Okay. We will have now is, what do you think you are doing? Come on, man. Jesus. Hey. My God. All right. Which is adding this now elements here to this stack. Oh my God. Anyway. So if we add this, element here, okay. Okay, so if we add this element here, so because we are now having a stack of each element, and if any of those stack, as we iterate through all of these elements, and at the end of that, any one of them is impair or is odd, then that's not a valid. If it's not, then it is valid. So based on this visual representation of the problem, let's now go to implement this. How can we do this? Glad you asked. So first thing first, we're going to define is our three stacks here. Okay. So the time complexity of this algorithm will be is OM because we need to iterate through all of those elements. in time, and in a space, it'll be is the number of elements that we have there, where if for example all of the elements are the same, that'll be is the same. So we are now creating is a stack of elements that in space in space complexity it'll be O n as well. So this is a solution with a time space. Exactly, this is a solution here. Solution with solution with empty solution with O n space and time. All right. So the longer the number of elements that we have here, the longer, the more time it'll take. Okay. So because of that, solution with ON, which is a space and time, like this, you got things like this. Now that you got is this, let's go to implement this. All right. So for here, we can just use the for of syntax here as a way to iterate through this, like so. And then we're gonna do is this value of string, that after all that's how we're going to iterate the scene. It's gonna provide us this string as an iterable by looking at the MDN here. Okay, this particular string, and if we take a look at this, strings actually behave as an iterator, right? String behave as an iterator. So to well formed, why is this? To well formed, what is this? Okay. Okay, that's interesting. Okay, that's quite interesting. That's very, very interesting. But in any case, the point of this is to see how now. Let's take a look at the looping here. So looping here, looping code. By using is the existing with break standard for loops. Exactly. This is the standard for loops. I want now to use is the for of, like this. Which loop type should you use? If you iterate through an array of some or some other object that's supported and don't need access to the index position of each item, then for of is the best choice. It is easy to read and there is less to go wrong. Exactly. It is easy to read and there is less to go wrong. For others, use for, while, and do while loops are largely interchangeable. They can all be used to solve the same problem, in which one of your use will largely depend on your personal preference. Which one of you find easy to remember or most intuitive? We will recommend for, or at least at the beginning, what it is appropriate for the easiest to remember everything, the initializing condition and final expression, and have to go nearly onto this parenthesis. But the thing here is that as long as this is an array, the question loop exactly loops and iteration, but especially with for of. Okay, so as long as it follows this, including array, maps, sets, arguments of objects. Okay, so as long as this is an iterable object, which means that my question is, strings are iterable objects? That's okay. Build interactions between the language and iteration protocol. Yes, building iterables are after all strings, arrays, type array, map, set, segments, and that kind of thing. Are also building iterables because of each of their prototype objects implement the symbol iterator, which is a batch method. In addition, the arguments, objects, and some done collections types such as nodelist are also iterables. There is no object in the core JavaScript language that is a sync iterable. Some web APIs, such as readable string, have the symbol.async iterator method set by default. Readable string. Generator function return a generator object, which are iterable iterators. Exactly. But in any case, built-in APIs accepting iterables. Map, weak map, set, promise.all. The building API accepting iterables. Okay. And built-in iterables. So it means that strings are iterables, which is in this case. So you're gonna get each one of those elements as we call this function. So with that, because we're going to define is now a stack here. 3 stacks, which will be is the stack parenthesis, okay. This will be stack curly, and the other is stack square. All right. So we represent all of this as an array, where the idea of this stack is that we can add all of these elements from the last one. So when you add elements to the last one element, you push them, and that's what we're gonna do. So if this string, we can also use a switch syntax, right? Switch. Okay, if the string actually match is one of these case, all right, case like this, case like this, if this is an opening curly braces, okay, this is an opening curly braces, and what you to do is this stack parenthesis dot push that string, okay, and we actually going to duplicate the same here for the closing one. And again, as you can see, I already made an error because it's not as, we need to actually do this parenthesis. All right. Then we have another case to evaluate, which is this. If this is now an opening curly brace, so you're gonna use this now the stack curly. All right, and here you're gonna push that element, that similar, but now in this particular case for the closing tag, in this case the closing curly bracket, like this, and then we're going to repeat the same for now the square bracket. If this is a square bracket, we're going to use this the square, is stack square. Okay, stack square dot push. This is saying is this. We're gonna do is a stack square dot push, and that's it. Yep, that's pretty nice. And the default is like not doing anything. It's like break. Yeah. Break. If there is nothing there, so break. So after we do this, okay, then we want to check if that actually is paired. Why is that? Because as we mentioned here, if that is paired, it means that they are now each one of those tag they are now actually is a valid parenthesis, and they are respecting is the order of this. So they are now so open bracket must be closed by the same type of parenthesis. Open bracket must be closed in the correct order, and every closed bracket has a corresponding open bracket in the same type. So if the stack so if the stack parenthesis dot length is their model, okay, is their model is a pair model equal to 0, which means it has pair elements, and we're gonna do this in we're gonna do the same now, but for the stack curly dot length. Hey, if those elements, when you divide them by 2, they are pair, they're 0, which means we have pair numbers. If it is gray, stack number here, stack dot length, when you divide them is also equal to 0. All right. If it is, then I want you to return is true, right? Exactly, true. Otherwise, return false. And that's it. It's a wrong answer. Output true. If the stack parenthesis if the stack parenthesis dot length their models is equal to 0, and the question is that are you evaluating this as expected? Of course. Now, of course, it's doing that. It's because, yes. So as long as the stack parenthesis, okay. So as long as the stack parenthesis contains something, okay. So as long as the stack parenthesis contains something, and okay, as long as the stack parenthesis contains something, and their models, okay, is equal to 0, and as long as the stack curly contains something and their model is this, and it has an even number of elements, and as long as the stack curly here, in this case it's a stack square, sorry, my bad, and the square length here is equal to this, only then is when you actually say, okay, return true for that. In this particular case, it's actually returning as this is the stack parenthesis, stack curly, and stack square exists. Okay. Perhaps it's our conditions here. Let's actually match. Let's not match. Oh, but this was random. So if the stack exactly, if the stack exists and it has uh, an odd number of that, okay, so for example, if that contains an odd number, something like this, it means that this is not a valid one. It means that this is not a valid one. So if the stack parenthesis and the parenthesis length, so if that stack parenthesis exists, oh, I get it. No, I get it. I get it. If the stack parenthesis dot length contains more than one element, okay, and it has at least odd number, then you're gonna do this. So it's to only check if that. So if we got elements here, they must be odd elements. That's what we're doing with this check. If we got elements here, we need to, that must be an odd number. Alright, similar to this stay curly, but here is this dot length. Okay, if we got elements, those elements must be, so if we get elements, those elements must be odd in there. Is length similar to this dot length, but that's right. So what we're doing is, in this particular logic, we're saying is that, hey, if we got at least one element, that must be odd, whether it's in this stack or in this another stack or in this another stack, right? Otherwise, then return false. And it say, hey, this is a wrong case, because it's always returning false. That's quite interesting. Oh, I get it. No, I get it. Is this one? Really? If we got more than one element, which is after all we're evaluating that. If we have in each one of those stacks at least one element, all right, what is greater than 0, my bad. Exactly, it's greater than 0, my bad. So if we got at least one element, that length, the number of elements, that must be odd. So for example, here if we log this stack parenthesis the stack squared, okay. That makes sense. It's like not adding any element here. Oh, okay. Perhaps the switch, I'm not using the switch correctly. switching MDM. Switch an expression. You have break. Oh. Okay, I need to break that. Okay, and I need to break that. Yeah, it's because I am not that aware. Exactly. Oh, okay. It's because if you forgot a break, that is now continue to the next one, and 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 to the next one. Ah, I get it. Until all of that match. All right. Okay. All right. But even though it's still not adding that elements there. Why is that? Oh, because, oh my god, it must be the value there. Exactly. Not the string completely. And then you got is this, which is of course adding this twice here. Okay. Okay. That's why I asked the question of what is the value here? What is the value that I'm getting here? Is it supposed to be is the string? Exactly. My fucking god. It's all about is okay. It's because I didn't. Okay, there's some couple problem here. Most likely it's with the use of switch and the use of iterables here. All right. Okay. Is the use of iterable in. Now this will work. And the use of iterable with that. So now we can say something like this. Hey, if you get a length so if you get a length of 0, despite that it doesn't have, 0 is actually an odd number. Now you get this. So when we now submit this, all right? Oh no, I don't want to submit this, but anyway. It says that it must be in the correct order. Okay, it must be in the correct order. So the order here matters. Okay. Okay, so the order here matters, right? And because the order here matters, when you add one, then the another one. what are you doing? Exactly. When you say mod 2, it's mod 2, 0. That's right. Even if you don't have any value in there, it's actually valid, right? Okay. Yeah, because here we're checking is if they have the length of that. Okay. Here we're checking if they have the length. But the order here matters. Okay. And here is when we can now check if that the order here matters. Here is when the order here matters. So when you do this, so if there is an odd number of elements in each one of our stack, now we need to check, all right, what is the order inside of that? What is the order inside of that? We need to check is what is the order inside of that. Okay. 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 What is the order inside of that? Let me take a look now at this solution here as a way to solve this. I got some intuition here, which is now instead of actually putting each stack for each one of them, you're gonna use a stack, okay? You're gonna use a stack and a hash map as a way to count is the number of occurrence that you have from each one of those elements. Not only that, but as you add all of these elements, they must be close in the proper order. Exactly. Mm-hmm. Exactly. So we can adding as many as we wanted, as long as we are closing them. Mm, unless you have a hash map. A hash map. Mm-hmm. Mm-hmm. In space, time and space. Oh, okay. God damn. All right. Okay. I was somewhat close by using this. But again, I wasn't guaranteed that the order is matter. I wasn't guaranteed that the order matter. And the way to guarantee that order, okay. So, that'll be all for this video. Take care. Bye bye.